Solve each system by graphing, okay, and that's what we're going to be doing. We're not going to be using a table. We're going to be graphing, okay? So I need you to change these into a form that you can use. I think it would be probably just as easy for you guys to solve for y. So solve each one of these equations for y. Should take you just a few seconds to do that. I'll pause the video and we'll come back. But okay, so here's what we did. We subtracted the x, and that gave us the negative 2y equals negative x minus 3, and then we're dividing everything by negative 2. Okay, now, that right there should give me y equals, now here's the part I think is confusing to a lot of you. Well, first of all, this is the part that I circled right there. Do you know if that's positive or negative? It's positive. Now, a lot of you would want to say x over 2, but I have a feeling if you said x over 2, you would not know what the slope is. So that's why I say 1/2 x instead of x over 2, because you'll be able to see the slope. All right, now, the other fraction right there, negative 3 over negative 2, is that a positive or a negative? That's a positive. Now, I don't care if you write it as a fraction or a decimal. If you're a decimal fan and if you want to write 1.5 instead of 3 over 2, be my guest. There are, if you're not going to graph these, that's a problem for me. But whether you use fractions or decimals, I don't care. Because I know some of you hate fractions. Okay? It's a tad bit of a racism on your part that you hate fractions. But in fact, I think I'm going to make a whole comedian series on the racism in math class. Okay? So if you add 2x to both sides on the second equation, sorry for the mistake there, the second one is much easier, y equals 2x minus 3. Okay, so these are the two equations you've got to graph. Now you were saying, now is it the 3/2 that you were asking about that you said was kind of a hard place to start? That, would it make more sense to you if it was a decimal? 1.5.
Yeah.
Okay, use your calculator to find that place, and then you can find 1.5 on your y-axis, right? Now, be careful on your scale. Be careful on your scale. If the scale's the same, then you're all right. Technically, if you go up 1 and over 2, you would land right there. Do you see that? Do you see that every single block on this page is worth half a unit? Going up 1 and over 2 would be like that. Now, because the scale is the same on the x and y axis, you're going to be okay for those of you who put a dot right there. Because some of you did that. I know you did, because I watched people do it. Okay? But up 1 and over 2 technically is right there. I understand, because the scale's the same. Some of you put that dot in there. And so you have your line that looks like that. The other one, what was that? 2x minus 3? Okay, 2x minus 3. So probably better come down here to minus 3 to put my first dot. And then up 2 and over 1. So here, up 2 and over 1. Up 2 and over 1. Up 2 and over 1. Oh, wow, I found it. And let's see if I can zoom out so I can get a good graph here. Whoa, whoa, whoa. Oh, my goodness. Straight line looks a little bit wonky. Horrible. Okay. Now, answer the question. Answer the question. What's the solution? Solution is, thank you very much, 3, 3. Any questions on that? Okay. There are three terms here in this next question that we need to consider, and I'm going to help you with this. But one of the things you have to realize is you're not allowed to graph this. It says right there, without graphing. Now, I need to kind of have you help understand some stuff here. So let's see. That's good enough. What are you two doing over there? Oops, running out of room here. Inconsistent is one of the terms. Dependent is another one of the terms. And yes, you need to write this chart down, because if you're allowed to use your notes, you better have good notes. Plus, I'm giving you a grade at the end of the period anyway. Independent. Sorry, bad looking either. So these are the three terms: inconsistent, dependent, independent. An inconsistent system looks like two lines that look like this. In geometry class, what did we call two lines that look like they never crossed? We called them parallel, didn't we? Parallel. And how many solutions do parallel lines have? You know what I should write here? Slope, y-intercept, number of solutions. How many solutions does a set of parallel lines have? Remember, a solution is where they cross. None, right? So 0. They are never going to cross. What do you know about parallel lines? What kind of slopes do they have? Your choices are same or different. Same or different. What do you know about parallel lines? Same. They have the same slope, right? Well, if they have the same slope and they never ever cross, do you think they're going to have the same y-intercept or different y-intercepts? They would definitely have to have different y-intercepts. There's no way they could have the same y-intercept, otherwise that's the place where they would cross. Now, dependent lines are the same line. They sit right on top of each other. They are the exact same line. If they are the exact same line, then they have the same slope and the same y-intercept. How many solutions would they have? An infinite number, right? There's more than you and I could count. Every point on the line is a solution point because it's the same in both lines. Now, if your lines are not parallel and they're not the same line, how many times do they cross? Just think about two lines. In fact, I'll give you an example. Here's one. Here's another. Here's another. Here's another. These are all examples that I'm showing you right now are examples of independent systems. How many places do they cross? One time. One time. Okay? Every one of these that we've been dealing with so far is independent. Well, if they cross one time, what do you know about their slopes? Same or different? They are different. Now, I am going to cross off this last box. I'm going to just squiggle it out. And I want you to understand why. If you know that the two lines have different slopes, and you only have these three choices, isn't it obvious which choice it is? I don't care what the y-intercept is. As long as I know that they have different slopes, I know that it's an independent system. All right, now, let's go and look at question 6, now that we've got that chart, and now that we understand what those terms mean. So, right now, we're going to find the slope and the y-intercept for these two lines. So, use your algebraic skills, solve for y, that'll answer the question. So solve each one of those equations for y and show your work in your notes. In my first move here, what am I trying to indicate with this big arrow going to the other side? Move it away using which operation? Subtraction. So when I pushed it to the other side, I had negative 3x plus 5. How do you get rid of this negative? 1. You divide by negative 1. If I divide by negative 1 here and I divide by negative 1 here, what happens to that? It becomes a positive thing. And if I divide by negative 1 here, it becomes a negative. So you get y equals 3x minus 5 for that first equation. So what's the slope? The slope is 3, and what's the y-intercept? Negative 5. Okay, so let's move to the other equation. All right, tell me what I did first with that 9x. You subtract it to the other side, right? And if you subtract it to the other side, it becomes, whoa, gotta lock it. It becomes negative 9x. So what did I do to go from here to here? How did I get rid of that negative 3? Divided everything by negative 3. Well, if you divide by negative 3, you get a positive 3x and a negative 5. So we got a 3 and a negative 5. Okay, folks, I need you to answer a question for me. What do you notice about the slopes? Your choices are same or different. Same. And what do you notice about your y-intercepts? Same. Use your chart. Tell me which one we're dealing with. They are dependent. They are the same line. Every point is a point of intersection. Yeah, I don't want you to do this during the test. What kind of lines are these? Parallel. Give me the fancy term. Inconsistent, right? What about this one? What about this one? Thanks for paying attention. We've got inconsistent. What do we got now? Independent. Now, dependent, right? Inconsistent, independent, dependent. Because these are the same lines. Try to refrain from doing that during a test. You got your notes, right? It's not a cheerleading move, but you could. Yeah. Thank you for paying attention. Yes. I said that yesterday. Were you not listening to me? Okay, so will you be asking the same question tomorrow? Help her out. I haven't scheduled it yet. I got to look at my schedule. Okay, folks, without graphing, so I need you to find the slope and the y-intercept. Go. Put it in your notes right now. Come on, we're on the next question, which is question 7. Find the slope of the y-intercept. I don't care if you use fractions or decimals. It's up to you. Use whichever. So if you divide it out to 16. Now, I know there are a few of you that are fraction people. You know who you are. Okay? But I know a lot of you are decimal fans. So what's my slope and my y-intercept there? If you want to do 1/4 and 7/4, that's fine. If you want to do 0.25 and 1.75, that's also fine. It's up to you. Okay? What do I do in the next one to get y by itself? Divide by 12, divide by 12, divide by 12, and we end up with y equals 0.25x, right? Because that's a 1/4, minus 1.75. So I got 0.25 and minus 1.75. Okay, what do we know about the slopes? Same. What do we know about the y-intercepts? They're different. Okay, which kind of system is that? Which kind of system is that? That's inconsistent, right? Those are parallel lines. You need to be able to use the slopes and the y-intercepts to determine that. Sorry, was there any questions on that? Okay. Question 8. Get y by itself. Looks like I'm moving 2 things to the other side. So y equals what? This should be pretty quick. Negative 2x plus 4. That's true, right? Because those 2 things moved to the other side would answer that question, or at least that part of the question. Solving for y here, yeah, I'm going to move the 6x over to the other side, which gets me 3y equals negative 6x plus 3. Okay. Now what am I going to do? Divide by 3, divide by 3, divide by 3. Okay, y equals negative 2x plus what? 1. Okay, answer the question that they asked you. Answer the question they asked you. I guess I could say, or use chart. And by chart, I'm referring to what we talked about a few minutes ago with the independent, inconsistent, dependent stuff. So I would let you go either way on this particular question. Some of you will find it easier to use the chart. Some of you will find it easier to graph it. It's completely up to you. Let me check the items. Okay, getting it into solving it for y or graphing this, or why we chose no solution. I get it. Okay, so I've got 1 down to the right. It's a negative 2 slope. I would always do either up and down, but always to the right. Okay, so I'm either going to go up and over or down and over. Okay, but I'm always going to go to the right. If you graph a couple points that way, then if you want to go to the left, you can, so that the line stays straight. Let's see your notes over here on this side. I already saw yours because I told you that. Have a great day. Thank you very much.